Maybe you've heard some of the buzzwords everyone seems to be talking about when discussing the future of containers. Strange words like MicroVMs, unikernels, sandboxes. Have you wondered what these things are and how you can use them? Or, for that matter, should you use them? In this episode of Mobycast, John and Chris continue their 3-part series on the future of containers. We go deep on the most talked about MicroVM, AWS Firecracker. We learn how Amazon uses Firecracker and its tremendous benefits. We then discuss how to use Firecracker for your own containers and get the same great results. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts John Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, John. It's good to be back.
Yeah, good to have you back. So here we are today. We're in the middle of a series that is one of the hottest series ever on Mobycast. I'm so excited about this series. We've been talking about MicroVMs, and, nobody knows that much about them except for the people that are making them and a few people that aren't listening right now.
Those 5 people in the world.
Right. So, I guess we should get into a recap, but before we get into the recap, I guess a lot of what we're going to talk about today is going to be specifically about Firecracker. We're going to get into some more details. Where we left off last week, we'll do the recap, but I want to sort of kick off the recap with this idea that I had that, MicroVMs and how they work and how they're orchestrated seems to me, from what I've learned so far, to be inspired by how container orchestration and container runtimes and things like that work. So I was trying to draw some parallels between the two in my mind. And maybe we can keep that in mind, or maybe you can just totally disagree or flip it on its head for me, Chris. But in either case, maybe we can start with a recap.
Sure. Yeah. So let's first start with the recap. So last episode, we kicked it off. We kind of started off with hey, the current landscape is We've talked about virtual machines. We know about that. It's full virtualization, strong isolation, really great security story, but heavyweight. And then we have containers that came along, and containers are virtualization at the OS level. They're much faster, much more resource efficient. And not only that, they're virtualizing and abstracting at the application level, right? So it becomes this perfect natural unit of abstraction for us to do our cloud native apps versus virtual machines. Mm-hmm. You're virtualizing the entire server, right? So we just packaging ends up becoming a lot more difficult, right? If it's a VM versus a container. And so we want to deploy apps, not servers.
Yes.
So containers has that rich ecosystem, right? That really supports us on that. But now, the issue that we're faced with is by getting that great abstraction at the application level, and we have this great speed and performance, and we have the resource efficiency, we gave up some of that security benefits, right? Because it doesn't have that strong isolation. So now we're kind of looking back and saying, hey, what if we could have that isolation that we got with the VMs, but still keep this model of all the good stuff that we get with containers? And so that's where we're going here in the future. That's what there's a number of different techniques and camps and projects that are going and addressing that. And so we kind of introduced the concept of, okay, there's MicroVMs in this space. We also have something called unikernels. And then there's, another flavor would be like sandboxes for containers. And so so we're on that process now of let's go describe these things. And we started off with MicroVMs,
right,
explaining what those are. And now we're going through the treatment of 2 of the most popular MicroVMs, or the most active ones, and being Firecracker from AWS, and then Kata containers, which we'll be talking about a little bit later.
That was such a funny little catch, Chris. It's like you wanted there to be room out there for there to be a more popular one that's less active.
Yeah. Yeah, and the other thing is too, it's this is all pretty new, right? Especially in this concept of MicroVM space. a lot of contenders out there. And this is one of the things I hope we really kind of get across during these episodes as well, is just like, well, what does this mean to you? Like, do you have to do anything? Like, how do you take advantage of this, right? Like, is there anything you need to do? Like, what is that information that you need to know about? So we'll try to kind of help break that down as we go through this.
Spoiler alert is probably not that. Since it came out, you need to be using it in production. That's probably not the answer we're going to get to.
Yeah. Yeah. I mean, it's we'll go through it and we'll see what it is. But yes, chances are there's probably not a lot that you're going to have to do other than kind of be aware of some of these options. And so that actually is a good segue into kind of what you started off at the top by saying, like, hey, I'm kind of thinking of this as like there's a correlation between run C. And
just a quick reminder that run C is like a way of creating a container and running it. And then like the other process that we talked about with containers was container D. And that was a way of like looking across containers, like being able to see what's running and you know, how they're running and things like that. So container D is a daemon process, like a service that manages containers, and run C is like a thing that creates an instance of a container.
Right. Absolutely. So that defines the spectrum of the runtime support for containers. So container D is that high level runtime environment, and run C is the low level runtime. So run C is using the syscalls to go and create containers and destroy them. And then the high level runtime, container D, and this is all in the Docker space, right? There's other runtime systems out there and whatnot. But as far as container D and run C goes, that container D is that high level one that's now managing more at the abstraction level, right? Like it's dealing with things like containers and snapshots and images and whatnot, so that it's much easier to work with, as opposed to like, oh, what's the syscall for creating actually directly manipulating C groups and namespaces and whatnot. So in this space now, we want to, with MicroVMs, you're creating VMs first, right? And then the container, a container could run inside that. And so, what we're seeing with MicroVMs is like, they need a way to integrate into this ecosystem, right? So like we talked about, like first there was VMs, then there was containers, and containers have been around now for a long time. Very rich ecosystem with the entire tooling set, right? From start to finish, from when you start developing an app all the way to deployment and observability and monitoring and maintenance of that app. And so here's something, new that comes along. It can't be completely different, right? And disruptive. Otherwise you're throwing away all of that ecosystem, that tool set. So that's what these projects are looking at. It's like, how do they integrate into that, so that as far as like users are concerned, it's no different. So I think that's kind of like the primary, motivation that's driving these integration points, is they actually didn't really have much of a choice. The MicroVM implementers, right? They have to. That was the natural point of abstraction of integrating into the system and saying, okay, we're now at that level, like that low level runtime. But instead of it, as far as like everything above it, it's creating a container. But instead, we're kind of intercepting that. And first, we're going to create a VM, and then we'll create the container.
Okay, so the piece that I was kind of going along being confused, because I was like, I'm not talking about any kind of integration here. I'm just talking about managing, starting, stopping, and managing MicroVMs feels like a very similar problem to me than starting, stopping, and managing containers. So if I had never done this with MicroVMs before, I might be like, well, let's see how we do it with containers. Oh, look at that. There's a process that starts and stops them. And then there's this other process that manages them. That seems like a good way to do it. And so that was sort of my point. Not that the Firecracker process was the same as run C or doing the same exact thing as run C or had any integration with Docker or containers whatsoever, but just that it feels like the way the whole system is set up is inspired by the way containers are started, stopped, and orchestrated and managed. And then later, potentially, like if there's a sort of a quote unquote Kubernetes of Firecracker, I would be totally unsurprised. Like, oh. But what you're saying is a lot of the actual job, especially around the stuff in AWS, is to actually start a container when you're starting a MicroVM and run that container within the MicroVM. And in order to do that, you actually have to integrate with the container stuff. And so there is a point where the two meet, MicroVMs and container stuff. And that's also interesting. I have a lot to learn there. I'm not sure. I don't even know if we'll cover much of that in our episodes, but I don't think that that's the only thing that Firecracker is for, right? It's not just for running containers. It could potentially run other things, right?
It could, but I mean, this is really like the natural evolution, and this is, I think, like the primary use case for it, right?
Okay.
I mean, think about it. I mean, we have VM systems out there that are very robust. They full support and all the features and just everything that you need with VMs is already out there. Mm-hmm. So why would you need a MicroVM? And it's like, well, MicroVMs become necessary when you want to create like just thousands of these, right? And they're short-lived, or you just need them to be really, really lightweight. They don't need much in the way of emulation, and they need high performance, and then they go away, right? So it's kind of like that single process model almost. Thinking about it,
it's like a single container per MicroVM kind of thing.
Exactly.
Yeah.
Right. So, because so that is that is the primary use case driving this, and that's one of the reasons why, MicroVMs they wouldn't have happened if it wasn't for containers, right? Mm-hmm. So because that's the problem that it's solved. Like, there's really nothing wrong, let's say, with VMs being full featured and heavyweight. Like, if you're not creating lots of them and creating a whole bunch of them and then tearing them down and whatnot, right? So it's really driven by this use case of containers.
So by having Firecracker be totally tuned to run a container, then that's I almost imagine it like in like the sense of like biology, like, oh, it's like a receptor that's totally tuned to accept this protein. Like, you know what I mean? It's like the shape of a container has a thing that it needs, and Firecracker is it. Mm-hmm. I'm going to make, yeah.
Absolutely. AWS it tells you, right there on the homepage for Firecracker, right? It is purpose built, and they even go as far as for serverless applications, right? So this was built for Lambda. Mm-hmm. Mm-hmm. Like no ifs, ands, or buts. This was built for Lambda. So it was built for running functions securely in an isolated way at massive scale.
Well, maybe that's where my confusion was, because Lambda, when you talk about Lambda, you don't talk about containers. You talk about zip files, you talk about layers, all kinds of stuff, but you don't talk about containers. And if Firecracker is built to run a container, then that's the secret is, guess what? It's actually your Lambda function is actually running in a container, by the way.
So, maybe taking a step. So as far as like the actual implementation goes, like, does Lambda package your function as a container and run that? Probably not. It's probably just literally it is just doing the files. It's just a bare bones file. But again, it's kind of like this space of it's really just a single process, right? And whether it's whether it's packaged as a container or if it's not packaged as a container, it doesn't matter anymore, right? Because it's now isolated inside that VM. But so think of it more along the lines of just what's the minimal amount of feature set you need from a VMM to run this very simple thing. And it ends up being very, very similar for running a function like a Lambda function as versus like running a container as well, right? It's just, again, that purpose built for, like, think of it as like it's just a single thing running inside this MicroVM.
I don't know, Chris, you're doing a little dancing there. That was a little dance, right? Like, because we were like, Firecracker is just absolutely the perfect shape to run containers. And then it's like, well, but actually it also is the perfect shape to run Lambda, and that might not be in a container. So there might be like two. What does that mean? Does that mean there's a special Lambda firecracker and another like open source firecracker.
The difference between like a container and a function is they're just different processes, but they're all still just one process. Mm-hmm. Right, and they both need controls over.
I'm not going to let you get away with that. Like, yes, it's a process, but it's got special things about having C groups and what file system it has access to, what memory it has access to. It's like very, very, very specific process, and that's what I'm talking about when I talk about the shape of a container. And like I was starting to go down this rosy path of thinking like, oh yeah, and firecracker is the perfect shape to give that shape a hug. But then when I think about the shape of just some process that runs a function, like that could have a much smaller, simpler shape than a container. I can write a function in like 3 lines of code and run it. And that the process that's running in is not going to look anything like a container process. See what I mean? See why I'm sort of like, come on, man, I don't know about this.
Yeah, I mean, I get, again, like, so there's nothing specific to Firecracker for that, like locking into the shape for a protein so that these two things lock up. Other than it's like this is a VMM that is just doing the absolute bare minimum to run a server process, right? That doesn't have a keyboard, doesn't have a video display, or anything else, right? None of those bells or whistles, and we have requirements where we need it to be able to spin up really, really fast. We want it to be as resource efficient as possible. We want to be able to tune it and say exactly how much memory it gets and how much CPU it gets, right? And so those are the kind of like the primary characteristics that they have when they go build it, because that's exactly what Lambda is, right? But they just didn't go, so when they built it, they just said, well, we want a VM, right, in order to run that function. And then, so that's what they built, right? Is something, a VM that could be spun up very, very quickly, that could be totally controlled on resources from both the CPU and memory standpoint. It was really geared to running server processes, and to be very, very high performance. But it's still just a VM, right? That's running a guest OS. Sure. So then with containers, and now looking at, what can we do for things like Fargate or whatever else comes along? Well, it's just, you have this guest OS, right? That's tuned for, high performance server applications that don't need rich emulation of a bunch of different devices. So running the container runtime inside that guest OS, like you can absolutely do that. And why not?
Okay. And then I guess the last piece to help me pull this all together, I'm going to try to pull 2 threads together to do this. One is, I was reading a Reddit thread the other day, and this person was talking about Firecracker and said that they were reading the documentation in AWS and that they started getting confused because the Firecracker documentation started veering off into Docker land and talking about a whole bunch of Docker stuff. And they were like, why is Firecracker documentation talking about containerd and runc? I don't understand. And then at the beginning of this whole conversation, this complete, side journey we're going on here, we also were talking about containerd and runc. And I was trying to draw like very loose parallels between the Firecracker ecosystem and the Docker ecosystem, but you actually pulled them together and talked about integration. And then that actually confused me and caused me to think that there's always integration because that's all Firecracker can do is run Docker containers. And then I got corrected on that. But I guess my question is, why is the AWS documentation talking about Docker? Why did you start off talking about the integration possibilities with Docker? Is it just because it's a good fit, or is there something more specifically custom built for Docker into Firecracker?
All right, yeah. So let me try to frame this a bit.
Okay. So
Firecracker, in and of itself, it's just another VM. Okay. So how are you going to use that? So we're all running containers today, right? Like, how are you going to use that? And so think about it. Like if you said, oh, Firecracker sounds great, MicroVM, it's super performant and it's got all the security benefits of a normal VM, and I want to start using it. So like, what would that mean? Like something like ECS or Kubernetes or Swarm or whatever kind of, or just plain old Docker, like, well, how do you do that? Like, you would have to manually yourself set up, like, you'd have to run some command to spawn a VM, right? And then if you wanted, you could now install Docker or something inside that VM and now run all your containers inside that VM, but you didn't really get much, right? Because now you're running all your containers inside a single micro VM. So now if you want to have this tooling around it to say, well, I really want to create a micro VM for every one of my containers. Well, what's going to do that? I mean, you'd have to manually do all that stuff, right? So it would be a lot of work, a lot of heavy lifting that is really going to, like, everyone's going to have to do this, right? It doesn't make a lot of sense. So that's why. Or
if you didn't want to run in containers, let's just think of it from the other perspective. Let's say you're like, well, I've got my micro VM right now, and it's got low overhead and it's got good isolation from the other micro VM. So I'm not going to take on the overhead of Docker. I'm just going to run my Nginx process directly in Firecracker.
So you could do it, but like that'd be like such a big step back, right? Because that's the reason why we went to containers to begin with. Is it gives us that repeatable, agile process of being able to abstract at the application level, and it gives us all the packaging, the formatting, just think about all the tooling that goes around with that. We'd be giving that up, and we'd be going back to, like, here's a jar
your
file,
micro VM,
right? Here's a jar file, and here I got to go install Tomcat, and I got to go install this patch, and it's just like we'd be going it would just be going backwards so much, right?
Unless you could create an image of your micro VM, right? Like, just do that and then throw those things around the internet.
Right, but then you'd have to do that for every single one of your applications, right? Or
which you already do for Docker, right? So if you could do that with Firecracker instead of having to do it with Docker, right? Because I'm just saying, Firecracker is using Docker because by using Docker, it's able to get away with not having to do a whole bunch of stuff that Docker already takes care of. So
actually, let me just point this. So Firecracker actually has nothing to do with Docker, right? In and of itself.
Oh, sure. Yes.
The Firecracker team is building integrations.
Yes.
To integrate in with Docker so that other people other than AWS can use Firecracker.
Right.
Right. So AWS, when they're running Lambda, like, again, they're not using Docker with this, right? They don't need Firecracker Container D, which is one of their integration. And that's what the Reddit user was talking about. They're looking on the Firecracker site, and they saw that, there's this thing called Firecracker-Container D. Like, what are they talking about in Docker and OCI and whatnot, right? Like, what are they talking about? And so that is the additional piece that they're building, right? To build that bridge between Firecracker and containers, because Firecracker in and of itself is not, there's nothing container specific about Firecracker. It's just a virtual machine.
Right. Okay.
It's just a hypervisor.
Fine. I just have to say this thing also, though, but as you can imagine, like, as you work on efficiency and performance and scale, there is still, between Firecracker and your running application, there's this container, and it has a lot of benefits around packaging and portability and things like that you could pull into Firecracker someday, and to make Firecracker even more efficient. Like, you could basically make it so that Firecracker was the place where that imaging and portability and same shapeness all took place, so that you could create Firecracker images, and you'd have a Firecracker image repository, and you could put Firecracker into your code pipeline, and you would remove, like, just that one little piece of abstraction that we don't technically need. It's just there because it's a lot less work for the Firecracker team to do when they can depend on Docker to do that for you instead of having to build it themselves. But it isn't for free, right? That's the point I'm trying to make. That container, like, spinning it up and running it, is like another couple microseconds that they could potentially get rid of. That's fine. Now I'm done. I've made my point.
Yeah.
But it's important, though. Like, that point is important because that's what AWS and the whole cloud infrastructure ecosystem is always doing. Like, where can we look at some piece of software that isn't actually accomplishing anything for us anymore and get rid of it? And then also, where is there software that we can turn into silicon? Like, those two things is what they're doing as they add more and more efficiencies. And in this case, it looks like there's maybe a little tiny bit of software that is owned by Docker that could go away someday.
Yeah, I mean, there's always going to be improvements to do to Firecracker on the roadmap, especially with the very specialized use cases. The one thing that I will firmly believe in, right, is at the end of the day, us, the users, the developers of applications, we want to we don't need to know about Firecracker. We want to work with containers, right? So we want to have our container. We want our Docker files, right? So that this is how we build containers. Like if we have to now go learn how to do a Firecracker build file format, right? Which is maybe a whole different way of building images. And I need a whole new tool chain for building those images, and running those locally, like on my local machine and whatnot. It just becomes this whole brand new thing where it's now I have to make the trade-off. Is it worth the investment versus if I can just...
Dude, AWS just announced that, and I've already started putting it in production.
We'll see you in 12 months.
What do you mean we don't want new stuff and we don't want to change every week?
Well, I mean, that's a whole nother episode we can talk about, right? It's just there's so much change going on, and how do you know when to actually pull new stuff in and kill your current best practices to revamp them and incorporate the new versus if you consumed everything that was new as it comes out, you'll just be spinning your wheels constantly and you're never going to get anything done. So there is some sort of pragmatic middle ground. And again, I think the good thing here is that for us, the container ecosystem is so rich. We're so efficient with it and we're so productive with it that doesn't need to change. Let these other things adapt to that, and we can reap the performance there, right? That's the undifferentiated heavy lifting. That
I like thinking of it as a protocol that we like and that we want to stick with. Yeah. So 20 minutes of off outline conversation, but it was really, really helpful for me. I think I feel so much better about how this all works and fits together and what it's for already with Firecracker than I did last week. But I'm sure there's some details on Firecracker that are in the outline that we want to get to and get into your head, Mr. Listener and Mrs. Listener and other folks.
Sure. Okay, so we can start the episode now is what you're saying.
Yeah, let's get started.
Perfect.
Dun, 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 dun. We cover a lot of information here on Mobycast, and if you've ever wanted to go back and remind yourself of something we talked about in a previous episode, it can be hard to search through our website and transcripts to find exactly what you're looking for. Well, now it's a lot easier. All you have to do is go to mobycast.fm/show-notes and sign up. We'll send you our weekly, super detailed outline that we use to actually record the show. A lot of times, this outline contains more information than we get to during our hour on the air. So sign up and get weekly Mobycast cheat sheets to all of our episodes delivered right to your inbox.
Okay, so let's pick up where we were last time. So last time we were going through Firecracker. We had kind of discussed what is it, and then also what are the benefits of it. So we talked about hey, you got really strong security, performance, and efficiency benefits. If you want to go back and listen to that episode to get the details on it, but there are some very strong benefits there with security, performance, and efficiency. So given that, let's talk a little bit about what's the status of that project and where's it going. So they did announce it. They released Firecracker at reInvent 2018, right? So it's been out now for a little over a year. They started using it in prod in 2018, so it's relatively new. And they have a roadmap. There's lots of new things to add to it. Some of the big things that they're working on right now that are enhancements in progress are support for other platforms, so specifically ARM and AMD. So currently it's supported on Intel x86, and so they're looking at expanding that out to be on other processor architectures. Another thing that they're actively working on is that integration in with containers, and specifically with Containerd. And we're going to talk about that a little bit more in detail in a little bit. And then another big thing they're working on is snapshot and restore functionality. So all virtual machine, technologies have the ability to snapshot, right, and to restore.
Yep.
So
I wonder what you would do with those images if you had them.
Excuse me?
Those are images, right? That's kind of what I was just talking about.
Yeah, absolutely. So it's a virtual machine image for sure. So you could absolutely come up with like this. Like, I mean, people do this, right? Like you have build systems in place now for people that are not on containers, that are actually just using virtual machines, and they go and their build process creates virtual machine images, and those get passed around and gets instantiated. So absolutely the same thing will be possible with Firecracker. So for folks that want to put in that tooling and do the work to do that fits their model, once snapshot and restore is there in Firecracker, then they would be able to do that.
Right.
Yeah. Lots of benefits too with snapshot and restores. So what we talked about last time, for a VM, a micro VM to spin up with the guest OS, looking at 125 milliseconds, pretty fast, right? But if you do it from a snapshot, they're talking 5 milliseconds.
Wow.
Right? So like just almost instantaneous that you would have an up and running VM if you are instantiating it from a snapshot.
Wow.
So I mean, again, if you have just a handful of core applications that you really want to tune for, and you have just thousands upon thousands of these instances that you want to have, then something like this is probably going to be really, really attractive to you.
Yeah, that's amazing.
Yeah. So their snapshots are minimal, and it's only it's basically just taking snapshot of the virtual machine state. So things like KVM internals and registry values and whatnot. It's snapshotting devices, so the user configuration and the virt.io internals, and then also it's doing a snapshot of the memory. That's kind of one of the really interesting things here, is that when it takes a snapshot of the memory, that produces it's basically a memory map file. And so like the great thing about it, so like think about when we spin up virtual machines, right, or containers, we say, this is how much memory we want, right? And it's like a fixed reservation. So we say, oh, this is going to get 2 gigs or something like that. But maybe your application only uses 100 megs, right? But it's still going to use up the full 2 gigs. It's going to reserve that. Well, with these snapshots, and because it's memory map files, they end up, if you were only using 100 megs when you snapped it, that's all it's going to use when it starts back up, when it restores. Yeah. So it's a very great, ideal way of compacting your memory usage and resource usage. So pretty interesting. So that's something that's actively they're working on. It's not yet available, but it will be. I would imagine.
Yeah, that's really interesting.
This year.
My mind just going off, and that whole like thought of like saving an application in its exact state and sending it somewhere and then resuming from that state. Pretty cool. Yeah. Pretty cool stuff you could do. Yeah. Absolutely.
So, I mean, and that's kind of like where we're talking about this stuff now, is that like this is all on the horizon. It's new. There's a lot of work going on here. Today, there's probably not a lot of stuff that you really want to do with it. But, going forward a year, 2 years down the road, like, who knows? I mean, we might see some dramatically different workflows with the support of other tooling and other projects and whatnot to, take advantage of some of these things. And we may see a different way of applications being deployed and hosted and how they run out in the cloud versus today, but still keeping our rich ecosystem.
Right.
So that's kind of where the Firecracker project is going. So why don't we talk about like, okay, now that we know exactly what it is and all these great things about it, like let's talk about, well, how do you use it? So there's 2 things I want to talk about here. One is like, well, so this was built by AWS. So let's talk about how AWS is using it, because that's one way that you do use it, right? Is via proxy from using the AWS services that are using it. And then we'll talk into, well, what if you wanted to use it directly yourself?
Right.
So as far as AWS goes, we've already talked about it quite a bit, that Lambda was definitely the first use case for this and the first customer. And so Lambda's been using this since 2018. And we talked about like they are now doing trillions of function calls a month running Firecracker with Lambda. So very much proven, right? Like this is a real thing. in the past, we've kind of speculated that Fargate is using Firecracker.
Right.
I've actually seen a bunch of references to other saying that, yes, Firecracker is being used by Fargate. Well, it turns out, like, no, it's not. They're still working on that. It's very much actively being developed. I think they're kind of really close to being to the point where we're ready to go to prod with Fargate using Firecracker. And when they do, I think we'll know, even if they don't tell us, we'll know it because there's going to be a price drop for sure. With
drop, and then also just like everyone might be like, whoa, look at this. Look at how fast my tasks are starting and stopping.
Yes.
Yeah.
Absolutely.
Wouldn't that be cool? Like if you've got to spin up like 6 containers, 6 tasks, and that's not that many, but you're just like, whoa, and now they're up. Like you press go and it's like, poof, they're up. Like that's not how it works today. So it'd be kind of neat if that is how it started working.
Yeah. I mean, I think so that's kind of an interesting, point is that, right now the way it works, right, is like if you're spinning up containers, if you're using the EC2 launch type, right, well, the VMs already exist. So there's not that overhead, right? So that exists. You're just creating a container inside of a VM that already exists. With Fargate, they're always over provisioned, right? For just exactly this case. So the odds of you, when you're spinning up a Fargate container, of them needing to spin up a brand new VM for you is very, very low, right? So because they don't want, because that's a bad experience, right?
Right.
Like think about how long it takes to instantiate an EC2, like to bring it up, right? I mean, you're talking
right, long enough for getting a snack.
Yeah. So
not really, but
So they're, well, I mean, it used to be like 6 or 8 minutes, right? Now it feels like it's more like 90 seconds or 2 minutes, but still, it's like if it took that long for your process to start, your container to start, you wouldn't be too happy. So they're really over provisioned there. So we get to reap the performance benefits of their over provisioning, but it's costing them a lot more in the way of resources and to do that. And Firecracker, they're going to reap just tremendous benefits from not having to do that as much. Yeah.
Well, and honestly, like I don't know if it's purposely put in jitter, like, because they talk about how fast things are, but it hasn't your experience with ECS, with both Fargate and EC2 being that, like, if you're swapping out a set of like 4 tasks or 4, you've got four running containers and you're going to kill them all and put new ones in, that's not very instantaneous, that it takes some time. Like you can watch it happen and you're like, okay, now it's done. And it feels like with the kind of efficiency gains that we're talking about, that could be nearly instantaneous. So it's like I click the button and okay, yeah, it's done.
Yeah, and so Firecracker is not going to help with any of that you see right now.
You don't think so?
No, it absolutely, because all that time
because of the over provisioning.
No, all that time and delay is actually coming from the orchestration, right? And it's like one of the things that you have is just draining from ELBs, right?
Yeah,
so there's like by default, it's a 5-minute drain period from ELBs for your task. So it basically stops routing traffic to that task, that instance for as soon as you want to take it out, but it waits 5 minutes before killing it. So just by default, it's going to take you 5 minutes to deploy a new version of your container on ECS if you don't change that, right? So, and that's to deal with the count. Like, what if you have long running transactions? So there's this. So there's a lot of complexity that's just built in between the orchestration integration with other services, and so like I said, the overhead of actually spinning up a VM, like that performance benefit here we're not going to see much difference. From a practical
that's really unfortunate because it's where I want a lot of performance increases. It's like, talking to developers, there was a time when things were simpler where you could have like, you could just you make a change on your code, refresh your browser, and you see your change. And the like loop is very, very short. And there are ways you can still make that happen. But there's some trade-offs around that happening because like you're not really working in a real system when you do that. You're not working in a distributed system. So you want to be able to test your code in the actual cloud in its real environment. And it just seems, just my little rant is like, it would be so cool if I could kind of click a button in my IDE or hit enter at the end of a CLI command that basically said, replace what's running in my ECS services with this new thing. And like, by the time I refresh my browser, it's already done and I'm already seeing the new thing and it's running, it's real. And it's all, everything is still behind load balancers. Everything is still connected to real databases. Everything is still running on real, Fargate machines with MicroVMs, but it's all fairly instant. I think that if a cloud provider can get closer to that experience, everyone's going to be stoked. Like making the whole provisioning of new stuff faster so that we can work with real stuff in real environments and change it and see instant results instead of minutes long results would be so cool. That's what I want. Do that, AWS, please.
Yeah. I don't know if you saw many of the presentations at reInvent had the triangle slide, the pyramid slide, showing their priorities. And top priority is always security, then comes availability, and then performance, right? So that might be a little bit of a hint of like why they've made some of the trade-offs and why things work like this and why they, we talk about things like blue-green deployments and canary deployments. Right.
And I guess, while you wait for your CloudFormation to run is a nice time to have a lightsaber battle. So.
Yeah. But the old meme or joke about I got to compile, so go get coffee, right? So there's always got to be something where it's like, got to go get coffee.
CloudFormation today.
Yeah. All right. So moving on. So that's Lambda. So the other. So they are actively working on Fargate to use Firecracker, and this is like one of those just really key important things for them to do. And the reason why is because with Fargate, like again, we talked about that pyramid and we said security for AWS is always top priority. What they're doing now with Firecracker is for security reasons, they will only run a single task in a VM. Like they will spin up a new VM for every task.
Right.
So this is that is really expensive, and that is a lot of potentially wasted resources. Could you? I mean, think about if we did that, that means that we would have an EC2 instance for every single one of our tasks that we wanted to run. Which gives up one of the great benefits of going to containers is we can actually have that compaction, right? Where we can say instead of we don't need to have that. We can have 10 of our containers run on a single EC2. But we're in an environment where we're allowed to do that. We can be multi-tenant because it's all of our code. But with something like Fargate, there's not that guarantee. It is basically multi-tenant, where all AWS customers are using it. So they went with, they knew from the very get-go, this is what we have to do. We have to have a dedicated VM for every task. So there's a big overhead there. And so if they have, tens of millions of Fargate task launches, that means that they have tens of millions of EC2 instance launches, right?
Right.
So with Firecracker, once they have that in place, now they can run each one of those tasks inside a Firecracker VM.
Right.
And those Firecracker VMs can now run on bare metal instances. And so now you can run multiple tasks on the same instance securely. And so now they can have the same tens of millions of Fargate task launches. Now there's going to be tens of millions of Firecracker VM launches. But those are going to be much, much faster. And now they can have a much smaller set of bare metal instance launches to support that. So they're going to get much, much better resource utilization there and just scalability that they get. So that's definitely one of the things that they're looking to do with this. We've talked a lot about security, because it's a virtual machine, right? There is that strong hardware isolation boundary through the hardware virtualization.
Right.
And so that allows them to do this, to run on bare metal and have multiple tasks running on the same bare metal machine. There's some architecture details as well about how they get to implement this. And with Fargate, there's you have a customer ENI for your task, right? And so when we talked about this back in the Fargate mini-series about setting up the task networking and AWS VPC mode, and you're basically spinning up an ENI inside your VPC. That's the customer ENI, right? So there's that, and then there's also a Fargate ENI, right? So there's a Fargate agent. So just like we have ECS agents for the EC2 launch type, there's same kind of concept in Fargate, right? There's some agent there on that machine that's talking to the Fargate control plane. And in the current environment, there needs to be a Fargate ENI per each a Fargate agent for each task, and that ends up being like lots of overhead, right? To have,
I can see that. Versus
now with Firecracker, they're going to be able to have a Fargate agent per bare metal instance.
Interesting,
right? So it's there's some pretty interesting architecture diagrams out there for both of these situations where it shows like how it actually is stacked together and works. But I think we can kind of keep it at the level of the sayings like Firecracker is really allowing for not just this strong security and isolation, but it's also very real in the way of really reducing the amount of resources they have. So they don't need nearly as many ENIs dedicated for Fargate anymore, and they don't have to have all these agent codes they don't take up a lot necessarily, but it all adds up, right? When you're talking about tens of millions of launches. So if it's 10 megabytes or whatever it is, right? Like multiply that by tens of millions, and that's something that's actually a big number.
Right. And talk about just the business opportunity for them with this is so incredible because say they are able to run all the tasks on half as many machines as they needed before. So they're saving half, right? And then they could pass on a quarter of that savings to their customers, and all the customers would be like, sweet. And then customers are happy and they're making more money than they were before.
Yep.
Like just what a cash cow that'll be.
Absolutely. Yeah. I mean, this is a very strategic, very important project for them. Talk about like ROI, right?
Yeah, that's what I'm talking about.
I mean, this is massive, massive ROI. And this is so much like for the, just going forward into the future as well. This is going to pay off in spades. And the kind of interesting thing too, I bet you the teams are not that big, right? So you talk about how many 2 pizza teams are involved with this. I think we'd be surprised at just like how few it is versus how much leverage it's giving AWS and how much, what that return is. So pretty cool.
Agreed.
Yeah. And then obviously lots of operational efficiency gains are going to get in Fargate through Firecracker. We've kind of touched on them. So you can now tune this to be the exact CPU memory needed with right sizing. They no longer they can have a homogeneous fleet of bare metal instances. Now they kind of have to have different instance sizes, right? Because they're doing it at the EC2 level. And so the different EC2 families, right, have different amounts of CPU and memory. And so that you can't run a task that requires two gigs of memory on a T2, right? It needs to be something bigger.
Right.
So they have to have this mixed fleet of instance types right now in order to support. And so they have complicated code to figure out where does it get scheduled and run, versus with Firecracker, they can do that at the micro VM level, and they can have just these bare metal instances, and they can compact themselves.
Just big ones. Mm-hmm. Yeah. Just go with big old servers.
Yep. Yeah. Cool. So that's how AWS is using Firecracker. And obviously getting great gains out of it. So the real question then is well, how do we use it? What does this, mean to us? Other than if we're using Fargate or Lambda, how can we take advantage of Firecracker? And so,
We can make a multi-cloud function runner or container runner.
Yeah.
And have that be our new company.
There you go. You absolutely could. And, who knows? I wouldn't be surprised if there's projects out there that are doing. I know there's a bunch of functions as a service, open source things and whatnot. So, so who knows? But so we already kind of talked about this a little bit. Like Firecracker in and of itself is just a VM, right? It's a VMM, virtual machine monitor. So you can use it as a VM. So you can use their tooling to create VMs and tell a VM what you want your guest OS to be, and you can tell it, how much memory you use and CPU to use, right? But that doesn't. It's like I said, there's still, if you wanted to integrate that in with your whole your application set, then it becomes a lot of work now, right? To do that orchestration. So it's just a lot of work to be able to consume Firecracker in and of itself, right?
Sure.
So there's projects out there that are working again to integrate into this container ecosystem, right? Because that's what we want. We want our containers. Like, remember we had our chant last time. What do we want? Performance and efficiency. How do we want it? Secure and isolated. And so so that's what these projects are doing. So the Firecracker team, they're working on container D integration. So they are working on Firecracker version of container D. So it's a replacement for the standard container D daemon. It's actually custom compiled to have one of the control modules that's needed for Firecracker. So there's a bit of work there for whoever does want to use this. You have to go and have this custom compiled version of container D just for Firecracker, but it is it's compliant with it, right? So it's and you can now use either run C or Firecracker as your low level runtime for container D, right? So if you're using the Firecracker -container D, then having Firecracker as your low level runtime is now an option in lieu of run C.
Interesting. So that is the thing that I was kind of alluding to earlier. Like, what if we had Firecracker images in a Firecracker image repository? And so that's kind of what that's for. Yeah.
Kind of, although it's like you're still
kind of moving in that direction.
Well, you're still dealing with container images. It's just that the low level runtime that normally is dealing with just containers, it's been updated to be smart enough to say, well, before I create my container, I first need to create a VM in which to place it.
Okay.
Right?
Okay.
So,
never mind.
So it's doing some value added work there, but everything above it is just saying create a container. Right? So that's how it plugs into this tooling, so that like, again, you as a user of it, you don't have to really know anything about Firecracker. You're still you're just containers, and all your tooling above that level is all it sees is containers.
So you would use that if you were like running on-prem and you were making your own little platform as a service, and you realized that you had been doing it with Kubernetes before and using regular old Docker containers, and you're like, actually, this is kind of dangerous because our platform as a service has different applications running on it that really we should be keeping more isolated from each other. Let's pull in Firecracker to be our runtime for the containers. You can use Firecracker Container D, and now all of a sudden, all your little containers are running inside Firecracker VMs, and are more isolated from one another. Yes.
Mm-hmm. Yeah, I mean, okay. So that's again, that's definitely one of the big use cases that we're using MicroVMs for that strong isolation. So so if folks are,
and I like to go to the platform as a service example kind of immediately, because it's sort of like everyone gets it. Oh, I can imagine, Capital One has their own platform as a service for their own internal apps. Like, it just makes sense that they might have that.
Yeah, absolutely. So that's container D for Firecracker, and that kind of gives us the integration in with our normal Docker tooling, if you will. There are some other projects out there kind of doing the same thing. So there's something called Ignite from Weave, and basically, this is the same kind of thing, where it's now allowing you to run Docker and OCI images within the Firecracker VM. So it's just a different approach. Basically, it's hooking into that same place. And then they've also gone a step further, and they have something they've built called Firecube. And what Firecube is now it's hooking into Kubernetes and its container runtime interface, CRI, to now work with Firecracker. So it's
so
actually
as Kubernetes is deploying pods and running them, it's actually making Firecracker VMs with containers in them.
Yeah, and so it truly is probably at this point like the easiest way if you wanted to consume Firecracker yourself for your like own self-hosted container runtimes. Then definitely the most mature option out is if you are running Kubernetes. So using something like Firecube and Ignite. It's there, it's real, it's live, and it's plugs right in and uses it versus on the Docker side. I guess Swarm. There's no equivalent thing for Swarm, and then I guess ECS. We've kind of know what's going on there. So that's Fargate. So I guess that does kind of cover most of it from a orchestration landscape.
Yep, super cool. I don't see myself cracking up in Firecracker, to use the word cracker twice, anytime soon, but it's really fascinating. Like I think the thing that I get out of this that I love so much is just that sense of directionality in everything that's happening in the cloud. Like when you see and understand containers, and then you see and understand container orchestration, and then and also before that VMs, and then now MicroVMs, it's like, oh yeah, this is all moving in a particular direction of like, more isolation, more efficiency, and better tooling. Like everything is just sort of refining those three things.
Absolutely. I mean, this is all just evolution, right? It's not revolutionary. Like this is not stuff really it's not even hard. I mean, you can totally connect the dots. Right? It makes so much sense. Like that. This is where we have gone. So, and the interesting thing, again, it's all being driven by cloud, right? It's just all being driven by that. So it's really, to me, that's kind of interesting. It's like it used to be PCs was driving the innovation, and now, PC, like I don't know what the numbers are, but it's like I don't think people buy desktop computers hardly at all anymore. It's really smartphones have replaced that, and other types of connected devices on the personal side, and then on the server side, it's all cloud.
Yeah. Well, awesome. I know we have more MicroVMs to talk about, so maybe we'll talk about the rest of it next week.
Yeah, I think we covered a lot today, and we spent a lot of time on Firecracker, but it is kind of like one of the front runners here, and really kind of important to just go through and talk about that to really understand what MicroVMs are. So yeah, I think next time we'll talk a bit about Kata containers, and spoiler alert, Kata containers. They were. In looking at this, it was a little bit confusing to me because they kind of claim that they're a lightweight virtual machine, but it turns out I think they're more. You can think of them more as like this is another type of like run C replacement because Kata containers actually require some other VMM, some other hypervisor, right? But this is one of the other popular projects out there. It's so we'll talk about that, and then I think we'll also then that'll be the time where we can really dive into unikernels as well. Because unikernels really align well with some of the same kind of goals that MicroVMs have and use cases, but they do it in a completely different way.
Cool. Yeah. Can't wait.
All right. Thanks, John.
All right. Yeah, thanks. Talk to you next week.
All right, see ya.
Bye.
Thanks for being aboard with us on this week's episode of Mobycast. Also, thanks to our producer, Roy England, and I'm our announcer, Stevie Rose. Come talk to us on Mobycast.fm or on Reddit at r/Mobycast.
Bye.